Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the unit which I'm going to discuss is about the application of smart sensors and devices, and the topic which I am going to discuss today is automatic robot control. So, as we talk about this automatic robot control, it's an interesting topic. So, which refers to the use of control system and the algorithms which enable a robot to operate independently without continuous human intervention. So the robot, what it will do is it will sense the environment and make decisions and perform the action automatically to achieve a desired goal. So it is a very critical technology which boosts efficiency, precision, and the safety across various sectors. And also it uses various technologies and systems to manage the robots effectively. So why there is a need for automatic robot control? First and foremost thing is it increases the efficiency. So due to this, the human intervention is reduced and the human error will be reduced and it speeds up the production process and safety improvements. So robots can handle dangerous tasks which minimizes the human exposure and the precision in task, so it can perform the task repeatedly with high accuracy. So this robot control means it is the use of a control system and the algorithm, so which would enable a robot to operate independently without continuous human intervention. And the robot senses its environment, makes the decision, and performs the action automatically to achieve a particular goal. So, talking about the key components of the automatic robot control is we can see that sensors, actuators, control algorithm, controllers, software. These are the certain key components of the automatic robot control. So first is all about sensors. So these sensors will collect the information from the environment. For example, let us consider proximity sensor, cameras, temperature sensors, and encoders. And then the controller, it is the brain of the robot. We can call this as brain of the robot since the microcontroller, PLC, or the other embedded processes will process the sensor data and executes the control algorithm and the control algorithms. So here we can talk about there are various types. One is open loop control, closed loop control, which is a feedback control, then PID control, and other certain intelligent controls like fuzzy logic, AI based controls, all can be used under automatic robot control system. And then the next part is the actuators. So here, so these will convert the control signals into physical motion. For example, the motors, servos, hydraulic or pneumatic system, etc. And then the power supply is the other important thing. So that would provide energy to all the robotic components and the software which is helpful in programming the application. So next is the working principle of the control system in robots. So here the sensors first will detect the environmental condition and then the data is fed to the controller. The controller will compare the actual value with the desired values. So control signals, they are generated based on the algorithm and the application. Activators will perform the required motion or action and the feedback ensures accuracy and stability. And there are different types of the automatic robot control system like the position control, velocity control, force or torque control, and the adaptive control. So first thing is the position control will control the joints or end of the other positions, and the velocity control will control the speed of the movement. Force will control the interaction force with the objects. And adaptive, they are automatically adjusted based on the condition. It adjusts itself. So the integration of these sensors, controls, and actuators makes the automatic robot control. So the control strategies of the automatic robots are, so as discussed earlier, so we have the open loop control, closed loop control, the hierarchical control, and the behavior based control. So these are the different control strategies used in the automatic robots. So in the closed loop control, it is based on the feedback which is obtained, and open loop control does not have any feedback. So the applications of this automatic robot control are like logistics, healthcare, agriculture, manufacturing, and exploration. So the industrial automation, they make use of these type of robots for assembly, welding, packaging, etc. And the autonomous vehicles and drones are also making use of these kind of robots. And in healthcare, the medical robots are performing the surgical system, and the service robots are mainly to clean and for delivery. These all comes under the exploration, and the smart manufacturing and IoT based robotic systems. So the challenges in the robot control are, we can see that the technical complexity. So the developing a good robotic system is really a challenging task, which involves a lot of factors like the system complexity, reliability concern, and ethical consideration. And it should be a safety one. The user who is making use of these things should be fear free, and the maintenance engineers are responsible for troubleshooting and repairs, and the operators, these all the stakeholders should be taken into consideration while designing a automatic robot system. So the future trends is integrating this robotic system with intelligence, artificial intelligence, cloud computing, soft robots, and the decentralized control will be the future scope of this robot control system. So the total overall mind map of this today's session is, we have seen what is automatic robot control system and what is the function and the integrated components of this automatic robot control system, as we have discussed: sensors, controllers, actuators, control algorithms, etc. And the execution type, we have the adaptive operation, repetitive operations, and the precise operations. So today's assessment is, which control method uses feedback from sensors to adjust a robot's action. So first is closed loop control. And what is the primary function of an activator in a robot in order to move the robot's joint? So these are the today's assessment questions. Thank you.